So
Okay,
let's
great.
go step by step through this presentation, page by page. And I will tell you the number of the pages, and if you can shift it, if you can change it when I tell you, that would be a good option.
Okay, up and down might work too. I'm not sure what the page numbers are offhand.
Okay, that's the first page what Keshe Foundation is working with. It's Keshe Foundation is space technology organization, and all development is it's focused to research in the space and what we are doing here. So if you go to the next page, number 2, Spaceship Institute is like teaching program of Keshe Foundation, and we are here to learn and to share the knowledge. Can you go to page number 3?
I think we've got to go up.
We are a little bit delayed. So
There's probably about a 20 to 30 second delay, something like that.
okay, anyway, I want to make a connection from the physics what we were learned in high school and universities, and to make a connection to plasma technology that we are working here at. And in page number 3, I tried to show the structure of the matter in particle physics. You can go from molecule to atom to nucleus, proton, and then they explain that inside the proton or also electron, there are quarks. The smallest particles are quarks. That's how they're explaining in particle physics. And if you go to the next page, number 4, we can see the measures of these fundamental particles. And atom is 10 to the minus 8 centimeter. Nucleus of the atom is 10 to the minus 12 centimeters. Proton 10 to the minus 13 centimeters, and quark 10 to the minus 14 centimeters. You can imagine that these are very, very small particles. And I would ask, how could they observe them? Or how can they know their properties? It's very difficult to observe them. Also, the electron, it's 10 to the minus 18 meter, and the diameter of the electron. So it's very difficult to observe this. Yeah, but I think we are a little bit delayed here. So if we go to the next page, number 5, there is structure of helium atom, and we can see how small the nucleus of the helium atom is. 1 femtometer, 10 to the minus 15 meter, and this is very, very small. And on the next page, there is structure of the neutron. How they explain it at particle physics. They have quarks inside the neutron, upside down, up quarks, down quarks, gluons, bosons. I don't know what. I don't want to go to this, but I just want to show the difference, how we look at plasma and how mainstream physics is looking at. And if you go to the number 7 here, I showed what, so some description about a neutron. Neutron is unstable when it's on its own, and it has lifetime or decay time about 14 minutes, and it decays to proton and electron and some neutrino. So, or there is another decay, proton, electron, neutrino, and also gamma radiation. That's from mainstream physics, and here is on the next page, number 8, is it shows decay of the neutron to the proton and electron, and release of energy. So we are looking from plasma point of view. We are looking at the neutron in the same way. It also decays to the proton and electron, as Mr. Keshe explained in the first book. And in mainstream physics, they're using antimatter, term in antimatter, and we are at the page 9, if it's possible. No.
On top with what's on top of page 9. Yeah, antimatter.
If you go, yeah, Rick, are we at the number 9 at the moment? Because here we are not sure if we show the right, if we are showing the right picture.
You want the antimatter and particle physics?
Yeah, yeah.
Or, oh, okay,
Yeah.
sorry. Okay, got that.
In particle physics, they are using expression antimatter, and here is the explanation. I don't want to explain it in this way. I just want to show what are they using. It's well, antimatter is a particle composed of antiparticles, which have some mass as particles of ordinary matter, but have opposite charge, and other particle properties such as lepton, Byron number, and such things. And when they encounter between particles, they annihilate themselves. And here's the definition of annihilation. And another if you go to the number 10, dark matter. In cosmology and astronomy, they're using expression dark matter, which is some kind of hypothetical method that are using in astronomy, and most of our universe they're explaining is composed of dark matter. Dark matter, and yeah, I told him. Are we at the dark matter page? Or? Okay. Yeah, let's go on the next one. And here, let's start with the explanation how we look at the plasma. And in first book, Mr. Keshe explained about matter, antimatter, and dark matter. That's why in first book, the terminology is adapted to the terminology of mainstream physics. What I showed you in previous pictures, this is just to make a easier relation between mainstream physics and plasma physics that Mr. Keshe is trying to explain to us. So in first book, there were still explanation was still with these expressions like antimatter, dark matter, and matter. And if we look at it, in this picture, like initial fundamental plasma of neutron, is it composed from antimatter, dark matter, and matter? I'm repeating again, this is explanation from first book. So that's easier to understand. And antimatter we know from particle physics, and dark matter is from cosmology. And physicists are not using it in small particles, but here we can see that we have dark matter or dark energy also inside the plasma. And as it was explained before, the property of neutron is, when it's on its own, is, if we go to the next page, number 11, we can see decay of initial fundamental plasma of the neutron, and neutron decays to electron and proton and some residual of light. And the structure of the proton and electron are the same. They have all these sub-particles, sub-energies inside. They have inside the electron and inside the proton. There are still antimatter, dark matter, and matter. If we go to the next page, number 13, we can see a little bit different picture. Well, it's the same, but with different terminology. Antimatter is not right terminology because there is nothing anti in this matter. Actually, this is the principal matter where everything starts in plasma. That's why in the second book and in the third book, Mr. Keshe went to different explanation, and we are using this understanding now. The structure of the plasma is composed of principal matter, and then when this principal matter or principal energy radiates out and it loses some of its strength, it transfers to transition matter, transition energy, and further on, when it loses more of its strength, it comes to the matter strength, and that's the point where we can observe with our senses, where we can observe these fields. But source of principal matter is are magnetic fields. When magnetic fields interact, they create gravitational field and magnetical fields, and this interaction creates principal matter, transition matter, and matter. So the source of all the matters are still magnetic fields. if you go on the next page, number 14, in this picture it's shown light as a plasma. When light goes from one position to the other, it transfers from spherical plasma to cylindrical plasma because it has less friction to travel in space, in environment. And this cylindrical plasma has inside in the middle, when we see the red, it's like a principal matter in the center, and when it radiates out, like that black part is transition energy, transition matter, and on the edges it's matter. But light has this very interesting property. It is changing when it travels through different environment. When it travels through to transition energy environment, the part which is on transitional energy field, it comes on the surface, so that it creates less friction and it loses less energy when it interacts with its environment. So let's go to the number 15. And here is the structure of the spherical plasma. The way we understand it now, we have in the center principal fields, principal matter, and this principal matter, principal energy radiates out and slowly loses its energy, and it becomes transition energy, and on the edges we come to the matter level, and it creates like magnetosphere of in a matter strength field. So this is like column barrier or magnetosphere of the planet, or the, it could be also how do they call it, heliosphere of solar system, but it's always the same thing. It's still some kind of barrier, and but we are using different names for it. So that's our understanding of the plasma, and I hope that you understand it in this way. If there are any questions, here is the presentation in two-dimensional, but we should see this as three-dimensional picture. It goes in all three dimensions. So let's look what we are doing in our lab. If you go to the next picture, we see the mobile phone, and with this simple mobile phone we can get all the materials that we need, almost all materials that we need to start experimenting in the lab. If we open battery of this mobile phone, we can go to the picture number 17, and we get copper sheets out of this batteries, and we can nanocoat these copper sheets. We explained nanocoating procedure in previous workshops, so I will not go to the details. If you go to the next picture, number 18, we see the nano-coated material, already nano-coated. And we will use this nano-coated material in the next. We are using this nano-coated material at next steps. Let's go to the number 19. There are still, it's another picture of nano-coated material. I just want to show this picture to have that you have some kind of better understanding and better view what we are doing here in our lab. If you go to the next picture, number 20, you can see another nano-coated material. Number 21 shows nano-coated copper wire from the from very close distance, and we were explaining this nano-coating and how we done this and the structure of nanomaterial in previous workshop. So if you are interested into this, you can just go to internet and search for previous workshops. On the next picture, it's number 22. It's shown bone as nanostructure. We were discussing this also in health workshops, and it was explained in very detailed way. Bone is also nanostructure, and I just show this as to compare it with nano-coated wire. It's similar structure. If you go to the next picture, number 23, there is another picture of nanostructure so that you can have better understanding. It's single material, it's gap material, and you have layers and layers of these gaps and gap material. So that's how you get nanostructure on the copper wire, copper sheets, or whatever. If you go on the next, number 24, you can see nano-coating in Coca-Cola bottles. I think people who are following us, most of them, they done these experiments and they reached nano-coating inside on copper inside the Coca-Cola bottles. And one interesting thing that you observed is also that plastic of the Coca-Cola bottles is nano-coated. Let's go to the next picture, number 25. Here is the picture of nano-coated wires that we are using them in GANs production cells. On the next picture, we can see these GANs production cells. So number 26. This is our first setup in our lab. So let's go quite quick through these setups. Number 27 shows only one bottle in this setup, and we can see collection of GANs in one cell. On the next picture, number 28, you can see fat on the top of one of the cells. Mr. Keshe was also explaining this an hour ago about how how oil is created in our planet, and this was disclosed also in one of the papers that are available on the web page of Keshe Foundation. Let's go to the number 29. It's another picture of this fat on the top of the cells. The same thing. The people who are doing experiments at home, they can observe this. So everybody can check this. It's easy, quite easy process, and if you follow all the workshop, I think it's not difficult for you to replicate these experiments. On the next picture, number 30, it's another GANS setup for copper oxide. If you go to the number 31, it's only one cell, which is a close picture of it. Let's go to the number 32, another fat on the top, but a little bit different structure of the fat. And if you go to the next picture, number 33, it's collection of GANs. What we are collecting out of our cells in this picture is copper oxide, GANs, and on the next, number 34, it's different color. It's all the setups are not producing the same material. They observe a little bit more or a little bit less of energy, and that's why we can observe different colors of GANs material. There are also mixtures of different GANs because our setups are not set up are not only for one GANs, and they collect mixture of different GANs from the environment. So let's go to the next picture, number 35. Here is again collection of different GANs and GANs setup. Number 36, it's concentrated collection again of GANs. Why I'm showing this? Just to show that this is first step or second step in the process. It's you can collect these GANs material, but at the next step you can use GANs in different so about GANs, we were talking about GANs quite a lot in previous workshops, but let's explain again what GANs is. GANs is a plasma. When I was showing you before the pictures from mainstream physics about plasma and structure of how do they explain? They're explaining that electron is plasma, proton is plasma, but they cannot see electron or proton. But here we can observe this material, GANs material, which is gas in a nanostate. We can observe with our own eyes. If you go close to it, you see small spheres, small particles, and these particles is one entity, is one plasma. we see this plasma because of interaction of magnetic gravitational fields, which are in the center of the GaNs of the plasma. Let's say copper oxide, and when this magnetic gravitational field interacts with environment gravitational magnetic fields, they create this magnetosphere, and this magnetosphere is observable to us. So we see GaNs material because gravitational magnetic fields of entity of GaNs, let's say copper oxide, but we see the matter like atom because of gravitational magnetic fields of environment. Gravitational fields, magnetic fields of environment are, let's say, much stronger when interact with normal matter, because normal matter it has inside like plasma of proton, plasma of electron, and when these two interacts, they create residual. This interaction of proton and electron creates another entity, which creates another magnetosphere of the atom, and this interaction again with magnetic gravitational fields of environment creates magnetosphere, and so that we can observe atom. But this is in a much lower strength. That's why it's smaller. But with GaNs, this magnetosphere expands further, and that's why we can observe GaNs. I hope it's clear enough. Let's go to the next pictures. Number 37, just different collections of GaNs material, gas in a nano state. It's plasma state. Number 38, again, another GaNs with a little bit different color. Let's go number 39. It's another setup for GaNs production. And you can see in some cells there we collect CO2 GaNs, in some of the cells CH3 GaNs. If you go to the number 40, you can see that when you connect power consumer or light, you can light LED with this cell. Energy production is part of this process, because when matter transfers to GaNs, it releases energy which is not needed. The energy that was holding together, let's say, proton and electron, and this interaction, magnetic gravitational field to hold them together, it's not needed anymore. When they come together and they create one entity, they release energy, and we collect this energy and we can light LED. So we can use this system also for energy production. If you go to the next picture, 41, you can see again different type of fat. This fat can be used in the next steps for health applications, for food production, and we will explain this in next workshops. So for number 42, again, fat on the top of the cell. Number 43. These are just different setups, and I'm sure that people who are doing experiments at home, they can show thousands and thousands of these pictures. So everybody can do this at home. Let's go number 44 again, different fat on the top. 45, another setup for gas production. 46, we can see also that gas is coming on the top of the cell. Number 47, again, close picture of one cell, and we see CO2 gas in this cell and gas on the top. Another on number 48, another picture of top layer of fat. 49 again, fat. And if you go to number 50, we have GANs collection, different GANs. Copper oxide, CO2, CH3, and we can use these GANs in next steps. I don't know, this is quite a lot of pictures now. Rick, you can just go quickly from all of them just to show what we are collecting in our lab. These are just simple setups that are in our lab, and we are collecting this, and most of you can collect this at home also. And it was for people who think that they cannot do these setups. There is GANs CO2 capturing kit available also to buy on the Keshe Foundation forum webpage. So it's easy to set up things. Let's go quickly to these different GANs, and maybe to number 60. Here is a black page, but if you can, it's a video here. I think it will be able to show how can we use these GANs. Next step is how to use these GANs. If you right-click and you have possibility to start the video. You can see the power cells. These are the power cells that Arman made. There are GANs inside and different nanomaterials. And okay, it's not on. Or you can, yeah. Yeah, but you can go to the YouTube of on Arman's channel, and you can see these power cells. And with these cells, it's GANs inside and nano-coated wires and not coated wires, and they're connected together. In previous workshops, we speak detail. We speak about all details about these power cells, so we can charge the battery with these cells. So we can use GANs for energy production. So this is showing one of the applications of GANs material, of plasma material. If you go to the next page, number 61, you can see the reactor, first reactor, dynamic reactor, which has GANs inside. And with this experiment, it was shown that GANs goes into the center of the sphere and creates like disc shape. And if you go to the next page, number 62, you can see GANs material inside the reactor. That's the picture that we get also yesterday when we opened the GANs reactor of Arman. Is the same structure. GANs is in this in the same shape. It creates like disc and on the edges of yeah, like donut shape. So that's what we are doing now. It was step by step. We first produced nanomaterial, then we produced GANs, and now we are using GANs inside of our reactors. And if you go to the next picture, 63, this is set up star formation of GANs plasma reactors, Arman's plasma reactors, which we are running now in our lab. And from this setup, you observed in previous 2 days, previous 48 hours, strong magnetic fields that were detected, and with very small energy that we are using to run motors, we were able to create strong magnetic fields that also Mr. Keshe explained before. So step by step, it's not such a difficult process. Everybody can learn. It's just important not to be ignorant, because knowledge is here for all of you to learn, and everybody can do this. If we go to the next picture, it's again collection of copper oxide GANs. Why I'm showing this again? Because on the next picture is another application, number 65. It shows GANs in our brain, which we have here in our lecturing room, and this brain can be also used as a control system of our reactors, as a storage, and it has different we can use it in different ways. You can go you can go to the number 66. 66, just close picture of GANs in our brain. You can see the structure. It's wavy structure. It's like structure in our brain. Number 67 is from different angle. If you go 68, again from different angle, and you have you can observe here changing of the color. It goes to the creamish color. It's the similar color than our brain. And on the number 69, it's again we compared our brain with brain of the human. just to compare that the colors are similar. So that's how we can use guns that we were producing in previous steps, and most of you can also use this at home, but let's do tests first here. You can do tests also at home, and you can send also your results, so you can learn. You can teach us also what you can learn. Maybe we missed something, so it's important that we share information with each other. And I think it's not. We should not limit ourselves. I would say nobody is wrong. Let's be open to different explanations, but not in a way that people are not doing any experiments and they're saying you're not correct. Let's be open, people who are following us. Let's share with your explanation, and not just to say you're not correct or you're wrong. That's what we were observing in the past few days. We achieved very incredible results, I would say, but instead of people sharing their experiments, they were they're trying to discriminate. I don't know how to say this. Okay, let's go to the next picture. Number 70. Here's the picture of the sun, and sun is also a plasma. The same as our GANs is plasma, let's say copper oxide is plasma, sun is also plasma, but in different scale. It's much bigger plasma. It's much bigger principal fields inside of sun if you compare it with copper oxide plasma. That's why it's bigger, and that's why we say it's quantity and sanctity. When it's smaller quantity, it's, let's say, CO2. If it's a little bit bigger, it's copper oxide. It's big. When it's even bigger, we have sun. Even bigger, it's galaxy, universe. So it's all the same. It's the same structure. I want to show you also the other reactors. What we are doing here, we have also other reactors which are with gases, but it's the same principle, just the different way how to achieve plasma inside of our reactors. Let's say in number 71, you see one of these reactors. We use different gases inside of these reactors to create plasma, and then once the plasma is created inside, we can manipulate this plasma and use it in different ways. Let's go quickly through these pictures. Number 72. You can see a close picture of it, and here is the magnetic field detector in the front. That's what we are using here to detect our fields. We have different types. This is for lower strength fields, and we have another one for higher strength fields that we are using now in our GANs star formation setup that Armin made. Let's go quickly through this picture. Number 73 shows the inside of the reactor. Number 74, it's another reactor. What is interesting at this reactor is that it has rings on the top, and these rings are connected to the center of the reactor so that we can measure plasma flow inside the reactor and to observe what is going on inside. Number 75, again, just to show sun and to compare sun as a plasma to our plasma that we have inside of our reactors. Let's go to the number 76. Here is a star formation. We are always using star formation because it's much easier to control our plasma and to achieve some results. What we are planning to do with star formation, it's easier to achieve this than when we have only one reactor. Star formation is always used in flying how can I say vehicles or flying objects that is used in to travel into the space. So also future vehicles to travel into space will have this star formation inside of the vehicle. And if you go to the number 77, you can see that also amino acids, building block of an amino acid is like star formation. You have oxygen, nitrogen, hydrogen, and a carbon, and they are in a star formation. And you can compare our reactors also with building block of amino acid. On the number 78, another star formation. We have three star formation now in our lab, and we are testing these configurations. Number 79 shows our lab, but now it's already changed. We are changing things, we are doing different experiments, but always the main structure is star formation. On number 80, you can see our solar system and different planets inside of our solar system. And these are like, also each planet, it's plasma on its own. It's similar like one atom has different electrons, different protons, and these are different plasmas. And you can compare our solar system with an atom. Also, atom has different orbitals, and here you can see it's the same structure. Is it atom or is it solar system? It's the same structure. Number 81 shows the star formation again, but in a little bit different configuration with 6 reactors. You cannot see all of them because some of them are in the back, but we can replicate atom of carbon. We have central reactor which has plasma inside and 6 different reactors around it, so we can replicate the behavior of the carbon with our plasma reactors. Number 82 again, to compare our setup with atom of carbon, it's similar structure. We can do tests and we can emulate, or what's the expression in English? Copy the atom of carbon. Number 83, it's another picture of solar system. It's the same, so it's always the same structure. Plasma of the solar system is the same as plasma of the atom. Just to show it again. Number 84 shows another structure of plasma. It's plasma of helium atom. This is also interesting, but I think we don't have time. Maybe we'll go to details next time, because helium is similar. We can compare it to the plasma of the water. If we see it like the electrons of the helium are like two hydrogen atoms that are circulating around the oxygen atom. It's actually when we look at the molecule of water as one plasma, that's how we should look at it. It's actually like plasma of the helium atom. But let's go to these details maybe next time. We can talk hours about this, I think. Number 85, there are different pictures of our GANS production cells, of our planet Earth inside of solar system, about our star formation in our lab or our galaxy. It's the same thing. It's again plasma. It's the same process. So I just want to finish this with just few pictures. 86. We should not limit ourselves. We should try to expand our knowledge. 87. Yeah, why we are here? We are here to share the knowledge of the universe, and Mr. Keshe is doing this with us. And I think here we as knowledge seekers really appreciate this. And we'd like to thank him to share this knowledge freely. So that's number 88. That's from us, Spaceship Institute. We try to share this knowledge with help of Mr. Keshe, and also with your help. I hope to get some feedback where we are, where is the understanding, so that we can know we can do the next teachings. What should we go to detail, and where to put more attention, so where are the weak points, whatever. So if there's any question, I hope that I was not too long.